Hello, Professor. Can you hear me?
Hello, everyone.
Yes, they can see you. They're all waving.
Apologize for not being able to on-site.
For sure. Yes, I'm sure you're busy all the way in Pittsburgh. So thank you again for taking the time and joining us. You've worked on such awesome things. So we're excited to have you and talk a little bit about them. So why don't you introduce yourself and your current specialties and interests?
Sure. Um, as the host, Imani already introduced, I'm an assistant professor in the School of Computing and Information at the University of Pittsburgh. Here, I direct the lab called, I name it as the Human Autonomy Teaming Lab. Basically, we conduct research on the human-robot interaction, human-centered computing, and user experience design. Our lab, regarding the methodology part, we leverage the methods using the data-driven and theory-driven to address the challenges in the human-robot interaction. The first aspect we focus on is we try to understand how the human interact with the emerging technologies. These days we have the social robots in the restaurant, in the museum. We have the autonomous vehicle on the road. We have the unmanned aerial vehicles on the fly. And we try to understand what is the human's trust in those autonomous systems, how the human's situational awareness of the environment when they collaborate with emerging technologies. And meanwhile, we try to use the data-driven methods to model the human behaviors when they are in intelligent system. So for example, how much trust do you have when you are interacting with a humanoid robot who is helping you to make the coffee? And by modeling the humans' behaviors when they interact with the intelligent systems, we try to propose those innovative design ideas to enable the safe and effective collaboration between the human and the robots. We want to make the artificial intelligence, make the robots explainable, make the social agent accessible for the people with disabilities. And one of the interesting projects we are working on these days is like these days, there are lots of autonomous vehicles tested on the road. And one research question we are asking is how human will behave when they interact with autonomous vehicle. Imagine you are a driver of autonomous vehicle. You are a driver of a human-driven vehicle. And how will you interact with that autonomous vehicle? If there is only one parking lot available in the parking space, will you compete with that autonomous vehicle to occupy the parking lot? Imagine you are a pedestrian. If there's an autonomous vehicle coming, will you cross the road by trusting the autonomous vehicles will stop in front of you? So we try to understand how the human interact with the autonomous vehicle as the road users or as the drivers. And then we want to model the human behaviors when they're in autonomous vehicles and design the explainable and effective and safe autonomous vehicle in the future intelligent transportation systems.
Fascinating. Thank you for that. When you gave that like kind of example question of would you compete with the autonomous vehicle, we heard from the audience, yes, they would.
Great. Yeah. So we have different types of scenarios. Like the compete for the parking lot is one of the scenarios. And for example, if you are in a three-way road and you and autonomous vehicle both want to merge into the center of the road, and will you yield to the autonomous vehicle, or will you compete and occupy the road first? And then that comes to a question, how should the autonomous vehicle be designed? Should they be designed as aggressive or conservative? If all the autonomous vehicle is designed conservative, will people bully those autonomous vehicles? And all this comes to the research, like how should we design autonomous vehicle that human would like to cooperate with them in the future mixed traffic environments?
Wow, amazing. Thank you. And so the University of Michigan has an interaction and collaboration lab where the aim is to understand how humans interact and collaborate with each other with autonomous agents and with robots, and to propose design solutions facilitating such interactions and collaborations. You are an alumnus of this lab when you were at University of Michigan. During your time there, what kind of research projects did you work on, and how did your understanding of human-robot relationships evolve during that lab?
Sure. Yeah, I graduated from that lab in 2021 with a PhD. During my PhD study, my research mainly focused on two projects. For the first one mainly focused on the drivers in a future autonomous vehicle. Like autonomous vehicle, when we say autonomous vehicle, it actually have different automation levels. Most of you may have a level 1 or level 2 autonomous vehicle, which means you may have the adaptive cruise control, you may have the lane keeping system on your vehicle. And the future fully autonomous vehicle means that the vehicle can drive by itself on its own, totally. And from level 0 to level 5, there are certain level called level 3. Level 3, like we call it conditionally autonomous vehicle. Conditionally autonomous vehicle means that most of the time the vehicle can drive by itself. And when the vehicle can drive by itself, you can do some non-driving related tasks in the autonomous vehicle. For example, you can talk to your passengers, you can read a book, you can watch a movie when the vehicle is driving by itself. However, the automation, the robots, they are not always perfect. It may encounter some situation that the autonomous vehicle cannot handle. And then the autonomous vehicles will ask you to take over control of the vehicle. And one of my projects in my PhD is to predict whether human is ready to take over control the vehicles when the system cannot handle it, and try to design an adaptive in-vehicle alert systems to help the human take over control of the vehicle.
You worked on a paper titled More is Not Always Better: Impacts of AI-Generated Confidence and Explanations in Human Automation Interaction. What were kind of the findings and conclusions in terms of human-machine collaboration for that paper?
Yeah, one of my research line is we try to design explainable artificial intelligence. As a human, when we interact with artificial intelligence, we always feel it looks like a black box. And we don't know whether we should trust it, how we should collaborate with it. In order to address this kind of challenges, one of my research areas is to design the explainable artificial intelligence. And this project, the paper we recently published, tried to study how should we design the interface of the explainable artificial intelligence. And the main findings is, as the title said, the title is more is not always better. Like when we say we want to design explainable artificial intelligence, we say we want to provide explanations to justify the actions of the artificial intelligence. And then what kind of information should we provide to explain the artificial intelligence? Some people may say that we should show the confidence of the system when it gives you the recommendation, or we should give the explanation or the reasoning of the system's actions. And this study is we try to visualize the explanation and confidence of the systems. And in this project, the application domain is in the simulated surveillance task. Imagine that you are in a battlefield and you work with or you control a swarm of unmanned aerial vehicles to detect whether there is a threat in the monitoring area. And you as a human operator, you need to control these unmanned aerial vehicles. And the unmanned vehicles has cameras to take the photos of the environment and send back the photos to you as a human operator. And you, human operator, you need to decide whether there is a threat on the photos sent by the unmanned aerial vehicles. This is very challenging because you not only need to control the unmanned aerial vehicle, but also to make a decision whether whether there is a threat in the pictures the unmanned aerial vehicle sent. So here we want to introduce an automated decision aid to help you detect whether there is a threat in the battlefield. And the main goal of the project is we want to study how much explanation and we should provide to the human operators to help the human operators build the trust in the automated decision aids. And we visualize the explanation using the object detection algorithm. Basically, we visualize the detected threats using the key bounding box and the key points, and we visualize the confidence of the systems using the numeric values. And our findings is surprising. So we find that more information is not always better. If you put all the bounding box, all the key points of the threats and the visualization of the confidence information, people actually have worse performance than compared to when only the visual information, compared to when only the visual bounding box is presented. This means that when there are too many informations is presented to the human to explain the automation's decisions, human will feel that, or I cannot process the information, the complex explanations in a dynamic and uncertain environment, so that they basically cannot, they may not be able to differentiate whether they should trust the recommendations from the automated decision aid. Yeah, so this is the main takeaway. Basically, more information is not always better to enhance the automation transparency. We should provide the most important information to the human to help them know the reasoning of the automation systems.
And in your own studies, how does trust affect the relationship between humans and machines? You talked a little bit about that, the findings of that paper, and a little bit about that. But what happens maybe when that trust is broken?
This is a good question. When you say trust, how trust affect the relationship between the human and the machine, I would like to say you've treated the trust as a noun. So trust, you treat it as like an attitude that an agent will help achieve an individual's goal in the situations characterized by uncertainty or the vulnerability. As an attitude, as a noun, I believe trust is a latent variable that could indicate whether you would like to rely on or comply on the recommendations from the robots or from the automated decision aids. As a latent factor, this means trust could indicate whether you will adopt the recommendations or adopt the system. For example, if you overtrust a robot, then you may blindly accept all the recommendations from robot, or you may blindly trust the robot to do all the tasks for you, and the robot may betray you, but you may not be able to know that. And there's another extreme is that you do not trust any robot or any autonomy. In that case, you may disuse or reduce your adoption of this emergent technology. So for example, if lots of people, you may say, I don't trust autonomous vehicle. So you may not choose to purchase autonomous vehicle. Or when you purchase a vehicle, you may not want those driving assistance systems to be installed in your vehicles. But like in some social media, we see there are some videos that some drivers of the Teslas, although the Tesla may not have those fully autonomous vehicle capability, but they overtrust the vehicle and they blindly believe that the vehicle can drive totally by itself on the highway, and they even sleep on the highway and let the vehicle to drive. And this, this already leads to some very severe collisions in our society. So I believe trust is kind of your attitude and could indicate whether you will use systems. Go back to your second question, like what if the trust is broken? Yeah, this is a very interesting question because when trust is broken, basically you will have a decreased trust in your partner, in your teammates, and depending on the outcome severity, you may have different levels of trust decrease. So for example, if you encounter a traffic accident because of the autonomous vehicles, and then later maybe you never want to use autonomous vehicles again. But if you the robots who who tells you, who forecast the weather tomorrow make a mistake, you may drop a little bit trust, but not that much. So I believe that the trust drop, the decrease of the trust degree depends on the outcome. And when trust is broken, people may think about how to repair the trust, how to rebuild the trust. And there are some different ways to rebuild the trust. For example, you can apologize. So maybe if your robot apologizes to you, you may not decrease your trust that much. And the robot can do the denial. So it just doesn't admit its fault, right? Or it can make some promise, or I will never make this mistake again. And then later, if the robot could consistently perform the task flawlessly, and maybe the human can rebuild the trust and collaborate with the robot.
They're clapping for you.
You.
And so the question is around those bigger systems that are creating the robots, or that people believe are creating the robots. How does that affect trust, as opposed to just the robot and the human relationship? What about those overarching systems that also play a role?
How does the developer of the robots influence the human's trust in the robot?
Yes.
Yeah. Yeah, I think this comes to like the ethical consideration of robot development. Like basically, so for example, if autonomous vehicle company says that all the vehicle from my company is aggressive, and then maybe the human, they will treat the developers of this robots, the developed companies of the robots, they will put their trust in the robots may transfer to their trust in the developers, because the developer, they design the algorithms, and basically the robots, they are driven by the underlying algorithms. So I somehow feel that people may transfer their trust in the robots to the trust in the companies behind who develop it.
For sure. So that would kind of take precedent over like the actual, just the robot.
Yeah.
Interesting.
And that's why lots of companies, like even for ChatGPT these days, they are thinking about like how to address this ethical issues when they develop this artificial intelligence.
A couple years ago, the long tail challenge being something that was an issue presented in autonomous vehicles, where they couldn't tell the difference between like the value of life of like a turtle versus like a dog or maybe even a human. Is that still a challenge that is being worked through with autonomous vehicles today?
Yeah, so like autonomous vehicles, they do different stage to achieve this autonomous driving function. The first is the perception. And the challenges you mentioned, like whether the autonomous vehicle will be able to differentiate the turtle or the human or the pedestrian. This is indeed a challenge. I believe these days, like the computer vision, it improves a lot, and people are always looking at those corner case and try to improve the perception capability of the autonomous vehicle. Not only using the cameras, but also maybe using the LiDAR, radar, different types of sensors. But like one of the drawbacks of this scenario is we do not really have lots of data points for the machine learning algorithms to be well trained. There are always those kind of corner case. Maybe as the audience said, and also like maybe the autonomous vehicle is not able to differentiate a billboard on the roadside versus a traffic sign. So there are always these kind of corner case, and one of what we could do is we could collect, we could improve our sensor capability. So, like those sensor companies and people try to collect different types of data and try to use a multimodal data streams to improve the prediction of the perception. Yeah.
Wow.
But
Yeah.
like I don't know whether the fully autonomous vehicle can be this kind of a dream can come true in one day. Like there are always corner case in our society.
Definitely, definitely. I'm sure it just builds up over time and helps over time as more and more data comes in. Well,
Yeah.
thank you so much to Professor Na. This has been amazing. And thank you to you all for coming out for our first Science on Screen event. So thank you, Professor Na. I think you're going to say something.
Yeah. Oh, yeah. Thank you. Thank you for inviting me to this event. And I'm very happy to share our latest research progress with you on the human-robot interaction. And so, so as a human-computer interaction researchers, I always believe that in the future, we as a human, we could collaborate with a robot and exploit the relative strengths of each other and achieve something that each of alone cannot achieve. And I hope like in the future, like the autonomous vehicle can be on the road to help us drive when we are not when we don't want to drive, and we as a driver or as a passengers in the vehicle, we can make the vehicle as a working and entertaining environment. And like in the future, the robots can be in the restaurant, in the museum, and in the hospital to help us to save our labor and make our life more efficient and safer.
Awesome. Thank you. And enjoy Robot and Frank, everyone.